We will be using percent to describe the concentration of the solution, and I'm going to explain what parts per million is to you, but we will not be doing calculations with parts per million. The concentration expressions given to us are always expressed in this way, where it has the amount of the solute in the amount of the solution. Even your drug concentrations are given to you this way. For instance, 200 milligrams per 2 milliliters. It's telling you how much solute in how much solution. Well, this is the same format that we use in solution concentrations that are expressed in percent or molarity or even parts per million. Now, notice that there is an arrow pointing to the amount of solution because many people want to call the denominator the amount of solvent, and it's not that at all. It is the amount of solution, and the solution is the solute and the solvent added together.
Percent concentration is the first concentration expression that we'll look at. Now, percent means per 100. So that means divided by 100, doesn't it? So if I have 35% ethanol, I can then write 35 ethanol per 100 solution, or write it in the fraction like I'm showing you here, because 35% means 35 per 100. And what we mean when we say 35% ethanol, we're basically saying 35 of it is ethanol, 100 of it is the whole thing, the solution. Now, after the percent concentration, there will be a designation inside a set of parentheses, either W over W or W over V or V over V. These stand for weight by weight or weight by volume or volume by volume. So when it says 35% weight by weight, it means 35 grams of the solute per 100 grams of the solution. If weight by volume is used, then it's 35 grams of the solute per 100 grams of the solution, 100 milliliters of the solution. And then if it says volume per volume, then it's milliliters of solute per milliliters of solution. Each one of these expressions will give us a fraction like we saw in the previous slide. So 35% ethanol, weight by weight, means 35 grams ethanol in 100 grams solution. The way that we make that up is we add 35 grams of ethanol to 65 grams of whatever the solvent is. Usually water is what we're talking about. 35% ethanol weight per volume means we take 35 grams of ethanol and we add water until we have 100 milliliters of solution. If we say 35% ethanol volume for volume, that means 35 milliliters of ethanol per 100 milliliters of solution. And to make that up, we take 35 milliliters of ethanol and add water until we have 100 milliliters of solution. And the reason that we have all these different expressions is density changes. 1 gram of water is not 1 gram of an ethanol solution. As you add a solute to a solvent, it changes the density. So it's important to say how you constructed this when you are looking at percent concentration. In the hospital, you will often see percent concentrations, and if it says 5% dextrose, it may say after it weight per volume. Then you know how it was put together and you can better accurately measure out things. So now what we're going to do is we're going to learn how we can use these fractions as conversion factors. I think you already have a good idea that you know that you will be using them to cancel out things in order to get what you want. But realize, you see, there is after the unit gram ethanol or gram solution. There is after milliliter either ethanol or solution. So this name ethanol, or whatever the solute is going to be important to be written there along with solution after gram or milliliter. it will help you think through how to do your problem. So when you write a percent concentration, make sure you have the name of your solute in the numerator of the fraction and the name solution in the denominator of your fraction. There's two different types of problems that you're going to see in this solution chapter. Either there's going to be a problem where you calculate what your percent solution is, or the percent solution is given to you and you're going to use that to do a conversion. So when you want to calculate the percent solution, if it asks you for a concentration, you're going to be calculating a percent solution. And so what you do then is you use this formula right here. Mass of the solute over mass of the solution times 100%, because it's a percent solution. So if you were given that 5 grams of glucose is dissolved in 80 grams of water, and it asks what is the percent solution, then you're going to use this formula above. So 5 grams is my mass of my solute, 85 grams is the mass of the solution. Notice it was 80 grams of water and 5 grams of glucose. The two of them together makes up your solution. Then we're going to multiply by 100%, and then of course we follow 5.9% with the name of the solute. The solute needs to follow the percentage so you know what the solute is. If percent concentration is given to you, what you need to do then is change it to a fraction and use it as a conversion factor. So there's two types of problems. One in which they ask you for a percent concentration and you use the formula to determine that, or one in which the percent solution is given to you and you use it as a conversion factor. Here's an example. What is the number of grams of sodium chloride in 20 grams of a 0.85% weight for weight solution? Well, the first thing you notice is that what's given to you is 0.85% weight for weight. This is a concentration, so you know you can write a fraction for it. 0.85 grams, because it says weight for weight, sodium chloride, then 100 grams, again because it says weight for weight, solution. That's my conversion factor. Now, the given, besides that, you never start a mathematical sentence with a conversion factor. You always look for the measurement. The measurement is 20 grams of solution. Now remember to write the word solution or whatever it is that comes after the 20 grams as in the beginning, because that will help you figure out how to write your fraction. So 20 grams is the beginning of. Now you're going to take 20 grams and you're going to use the conversion factor to cancel out grams of solution to go to grams of sodium chloride. You know you need to have grams of sodium chloride in the numerator because you want to get to that in your answer. And you know you need to have grams of solution in the denominator because you're starting out with grams of solution. Now you notice in the problem that it does not say 20 grams of solution right after the word gram, but it gives you it says of, and then it gives you a description of solution, so you know it's solution that you have 20 grams of. So now what I'd like you to do, this is a similar problem. I want you to pause and then try this problem and then press resume when you're through. So here's the problem in which they're giving you grams of erythromycin and grams of water, and it asks for the concentration. So the first thing you know you need to do is you need to get all the data out of the problem and set it equal to a variable, because you're going to have to use the formula for the concentration of solution. So we can see that 0.020 grams of erythromycin is the solute. 0.5 0 grams is the grams of the solvent. The solution concentration formula is that it's the grams of solute over grams of solution times 100%. The grams of the solute is 0.020 grams, so we can plug that in. And the grams of solution, remember, is not 0.5 grams. That's the grams of the solvent. You have to add the solvent, and you get 0.52 grams for the grams of solution. You multiply this out, and your answer is 3.8% weight for weight. Notice you're going to follow with weight for weight because you're using grams in the numerator for the solute and grams in the denominator for the solution. One thing to note is that you never press the percentage key on your calculator when doing these percentage problems. That percentage is basically a unit and is carried through your in your math. Do not press it as an operation on your calculator. Here's another problem for you to try. Go ahead and press pause, and then you can resume when you are finished. To do this problem, you notice first of all that the concentration is given to you. 15% volume for volume. So you know you're going to have three things to put in your fraction. First of all, 15 over 100 because it says 15%. Then it says volume for volume, so you put milliliter over milliliter. And then you must put in those names, acetone, the solute, in the numerator, and solution in the denominator. Now, the beginning of your math is going to be the given in the problem. The only given that's a measurement is 0.5 milliliters of acetone. Notice, I put acetone after the milliliters. By using that name, that will help you set up your fraction correctly. Because I'm wanting to go to how much solution, it says how many milliliters of a 15% solution, so I need milliliters of solution. That should tell you that milliliters of solution is going to be in your numerator. I need to cancel out milliliters of acetone, so that's going to have to be in the denominator. So I have 100 milliliters of solution in the numerator, 15 milliliters of acetone in the denominator. I multiply through, and you can see we get 3.3 milliliters of solution. Go ahead and try this problem, and then press resume when you are finished. To do this problem, again, you notice that the percentage is given to you. It says 3.5% of a platinum drug, weight for weight. So I have three things I put in that fraction. First of all is 3.5 over 100. Then weight for weight tells you gram over gram. And then the fraction has to have the name of the solute in the numerator and the solution in the denominator. The problem is 250 milligrams of solution. Be careful when you look at your prepositional phrase after a given. It says 2,500 milligrams of an experimental drug solution. The end of the prepositional phrase is solution, and many people will write 2,500 milligrams of the drug, but you have to read the prepositional phrase all the way to the end to find out what it is of. Next, we're going to set up our fraction so as to cancel out milligrams of solution. But you see, the fraction for the concentration of solution has grams in it. So the first thing I have to do is to go from milligrams to grams. Once I go from milligrams to grams, and you might have had 10 to the minus 3 grams over milligram instead of gram over 1,000 milligram, and that is fine. Once I have grams, then I can go grams of the solution in the denominator. That cancels out the solution, and then go 2 grams of drug in the numerator. This answers the question then, how many grams of the drug was he taking? And if you put this in your calculator and go all the way through to the end, you get that it was 0.22 grams of the drug. Parts per million is another concentration of solution that we use a good bit. Parts per million is very much like percentage. Percentage you really could call parts per 100. Parts per million is just like percentage, but instead of being per 100, it is per 1 million. So we can write for a parts per million solution, it's the number of grams of the solute over 10 to the 6, or 1 million grams of solution. We usually use this concentration for very, very dilute solutions. For instance, pollution, or maybe hormone concentrations in blood, anything in which the concentration would be very small.